Hello everybody, this is Mr. Arocena, and on today's lesson we are going to be talking about how to balance a half reaction. So the half reactions that we've seen are basically things like the reduction reaction and the oxidation reaction. If you remember from the earlier lesson, when we talked about redox reactions, you always have one reduction, one oxidation. So what we're going to do is we're going to talk about how to balance these half reactions. If you notice, a lot of the reaction equations you were dealing with in previous assignments weren't actually balanced. So we're going to show you guys how to balance them today. All right, so there are 4 steps when balancing a half reaction. The first step is quite simple because it's similar to how you balance a normal reaction, and that's to balance the atoms basically. Now the major atoms are basically anything other than hydrogen, oxygen and hydrogen. So you end up balancing things that are like the metals, non-metals outside of oxygen and hydrogen and so on. Then you balance the oxygens, but in a redox reaction, we don't balance oxygen simply by adding oxygen. The oxygen has to come from somewhere. So we'll balance them by adding water. Usually because the redox reactions usually occur in water, so that becomes our source of oxygen. The second or third step is to then balance the hydrogens by adding H pluses, because usually they are treated as being in an acid. This isn't always the case, but initially we treat them as being in an acid. So the acid becomes a source of H plus ions. And then finally, the last step in balancing this half reaction is to add electrons as necessary to balance the charge. So these are 4 steps. Your textbook describes this as you can remember this with the mnemonic. They call it major hydroxide, major OH. So this is the order you balance things in. Major atoms first, then oxygens, then hydrogens. Remember, oxygens, we have to add water to balance oxygens, and to balance the hydrogens we add H plus, and I'll put a note here. After that you balance electrons. Okay, so let's go through some examples, because you can see the steps, but unless you see an example it's a little difficult to understand this. Alright, so here's a half reaction, rubidium oxide to rubidium. It's obviously not balanced because on the one side we have oxygens but no oxygens on this side. Okay, so let's carry this out. So the steps listed again. We're going to balance the major atoms first, then balance the oxygens, then balance the hydrogens, and then finally balance the charge. Okay, so the major atoms, I believe, are already balanced. So the rubidium, there's one rubidium there, one rubidium there, so they're already balanced. So my equation will just look the same. There we go. So major atoms already balanced. Now we're going to balance the oxygens by adding water. So I have 2 oxygens there. So on the product side, I need to add 2 oxygens, so I'm going to add 2 waters like this. There we go. The 2 waters will provide enough oxygen to balance out the oxygen over here. Okay, next step, we'll balance the hydrogens, because we just added water, so we added a bunch of hydrogens. We added 4 hydrogens here, so we need to add 4 hydrogens here. And the hydrogens come in the form of H plus because it's an acid. Okay, and finally, oops, that should be plus. That should be, there we go. And finally, we're going to balance the charge. Notice I have a 4 positive charge on the reactant side and I have a 0 charge on the product side. So I need to balance out the charges. I need to basically get rid of these 4 positive charges, so I'll add 4 electrons here. Here we go. Now everything should be balanced. We have rubidium oxide, so Ru rubidium there, 2 oxygens, 4 hydrogens, 4 hydrogens, overall charge of 0 on the reactant side, overall charge of 0 on the product side. There you go. So there is how we balance this half reaction. All right, let's move on to the next example. All right, so here's another one. If you want to try this on your own, you can easily pause the video here and try this on your own. Otherwise, we'll just follow along. All right, so we're going to balance this half reaction. Let's see. So first step, we'll balance the major atoms. So in this case, the only non-oxygen, non-hydrogen atom is the chromium. So I need 2 of them. So let's put a 2 there. Second step, balance out the oxygens by adding water. So let me just write this out. Now I'm going to add some water. I need 7 oxygens, so I'm going to add 7 waters. So step 3 is balance the hydrogens. So I've just added 7 waters to my product side, so that's going to give me 14 hydrogens. So I'm going to have to add 14 hydrogens to this side. Go. And the last step is to balance the charges. So let's count the charges. Let's see, on the reaction side I have a total charge of 2 minus plus 14 plus, this is minus 12 on this side. On the product side I've got a total charge of 2 and 3 plus, that's 6 plus. So I need to get, let's see, this is 12 plus, this is 6 plus, so I need to add enough electrons, I think, to the reactant side. And I think I need to add 6 electrons. I think 6 electrons will do it. And that should balance out this reaction. Let's just count to make sure. I've got my 2 chromiums, I have 7 oxygens, 14 hydrogens, 14 hydrogens. Total charge here is -2, plus 14 is plus 12, minus 6 is 6. 2 times 3 plus 6 plus. There you go, everything's balanced. All right. Now I mentioned that these reactions are usually done in acids, but that's not always the case. Sometimes they're done in a basic solution, in which case we have to do, there's one extra step for dealing with basic solutions. All right, let's go. All right, so in a basic solution, here's the half reaction for a basic solution. So this particular this particular redox half reaction occurs in a basic solution. So the process is effectively the same. There's just one final step we have to add in at the very end, and that's to convert the hydrogens to oxygens by using this equation here. So this equation allows us to convert the H pluses to OH minuses, and I'll show this in a minute. Let's pull up my sketchbook. There we go. All right. There we go. Okay. So what we do, as I mentioned, is basically the same process. We're going to balance this reaction in the same way. So first we'll balance major atoms. So PB, whoops, going to HPbO2 minus. Okay, so my leads are already balanced, so I don't have to worry about step 1. Step 2, we'll balance the oxygens. So we have to add water to the reactant side. We need 2 oxygens. Okay. All right, step 3, balance hydrogens. So we need to add, I think, 3 hydrogens to this side. Pb minus pluses, and then finally we need to add electrons to balance the charge. Going to HPbO2 minus. This will be 3H plus, and I think I will need in total 2 electrons. Okay, now here, because this takes place in a basic solution, I have to somehow convert all of these H pluses to OH minuses, and to do that, we simply do the following. If you remember from reaction kinetics, how reactions don't always take place in one step, we're going to take advantage of that by showing the following. We are going to take, okay, so I need to get rid of my H pluses, so I am going to do the following. I'm going to put a bunch of H pluses on this side, a OH minus, and then the H2O. So this is how we use the equation that's mentioned up here, the water equilibrium equation. We're going to stick it right below, then we're going to cancel things out. So I need to cancel out 3 H pluses, so I will just multiply this equation by 3. And then we start canceling things out. So this gets rid of the acidic H pluses, leaves me with basic OH minus. This water will actually cancel out some of this water, so those two, and then we can put everything together. So this reaction will actually take place as follows. To HPbO2 minus. If you did everything correctly, the charges should still balance out. We have 1 H2O and then 2 electrons. All right, so everything should still balance after this step. So we get 1 PB. We have 3 oxygens. We have 1, 2, 3 oxygens. We have 3 hydrogens. 1, 2, 3 hydrogens. And a total charge of 3 negative. 3 negative, 1 negative, and 2 negative. So everything still works out. There we go. All right, so that's how we balance a half reaction. If you remember those 3 steps, and then this one final step for basic solutions, then balancing half reactions should not be too difficult. Balancing half reactions is one of the methods for balancing a full and complete redox equation. So you will need to know how to do this before we can move on to balancing full reactions. Because this is only half a reaction. So this, I think, if you look at this, this appears to be, I think, if I take the oxidation number of lead, that's 0. This oxidation number of lead on here is, I think, +2. So this is an oxidation reaction. This is, oh, I can probably just look at it here. It's an oxidation reaction. It's giving away electrons. So yes, so this is only half of a redox reaction. So now we can balance half of the reaction. In order to balance the full reaction, we're going to have to do a few more things. Okay. All right. I highly encourage you guys then to practice this on your assignment. which is as follows. Do as many as you can. And yeah, as long as you follow the steps, don't skip anything and take your time at first, then you should be perfectly fine. All right, have fun with it.